Good morning to one and all. I am Dr. M. Bhaskaran from Department of Mechatronics Engineering, K.S. Rangaswamy College of Technology, Tiruchenkodu. Today I am going to handle a topic on strength of materials, which is one of the very important topic for GATE and other competitive examinations. The topic is columns. What is column? A column is defined as a member of structure which is subjected to axial compressive load. There are two important things are there. One is column and another one is strut. The column is a vertical member which is fixed at both ends rigidly, where the same compressive load is acting. Then that is known as column. If the vertical member is, if the member of structure is, or the member of structure or vertical member is not vertical, or and one of its end is not fixed, mean that is strut. If not fixed means that end may be hinged or pin joined, or it may be free, then that is known as strut. The example for column is a vertical pillar between roof and floor. The example for strut is connecting rod and piston rod. How a column will fail? The column will fail in two ways. One is direct compressive stress. The second one is buckling stress, and the third one is combination of these two. The combination of direct compressive and buckling stresses. These are the three major reasons where the column fails. Okay, there are two types of columns are there. One is short column, another one is long column. What is short column? The length of the column in comparison to its lateral dimension is low. That means less than 15 means the column is known as short column. If the length of the column in comparison with its cross section is greater than 15 or very high, then the column is known as long column. Okay, the short column always will fail only due to crushing. The crushing load can be calculated by load by cross section area. The long column is nothing but the column in comparison to lateral dimension is very high, that means greater than 15. Then the column is known as long column. Long columns fails due to buckling load only. The column, the crippling load or buckling load can be calculated in three ways. One is there are different theories available. In our subject point of view, only 2 to 3 theories are very important. First one is Euler's column theory. Second one is Rankine's theory. These two theories are very important. Apart from this, some of the 2 to 3 theories are available, which we need to refer. First one is Euler's column theory. What are the assumptions made in Euler's column theory? In Euler's column theory, the column is initially perfectly straight and is axially loaded. The section of the column is uniform before and after bending. The column material is perfectly elastic, homogeneous and isotropic and obeys Hooke's law. The length of the column is very large compared to the lateral dimension. Then only it is considered as long column. The direct stress is very small compared to bending stress. The self weight of the column is neglected. The column will fail only buckling, not compressive. There are four important end conditions for long columns. Okay, these four conditions are shown in the diagram. First one is both ends are hinged. Both ends are hinged means both ends are pin joined. The second one condition is one end is free and the other end is fixed. And the third one condition is both ends are fixed. And the last one is one end is fixed and the other end is pin joined. These are the four important conditions for long columns. The another important term is effective length or equivalent length. The effective length of a given column with the given end conditions is the length of an equivalent column of same material and same cross section with hinged end. Okay, only we need to compare any other conditions into hinged, we need to convert the any other condition into hinged end condition, that is known as equivalent or effective length. The material is same, cross section is same, but the end condition is both ends are hinged. The important is, so far we have seen buckling load or crippling load, both are same. Buckling load or crippling load is nothing but the axial load at which the perfectly straight column start to bend, that is known as buckling or crippling load. Another important term is slenderness ratio. It is nothing but the ratio of actual length of the column to least radius of gyration of the column is known as slenderness ratio. We can calculate the slenderness ratio by using the simple formula I equal to AK square, where I is nothing but I is moment of inertia, and A equal to cross sectional area, and K is nothing but radius of gyration. From this we can calculate K. K equal to I by A. We can calculate the K least radius of gyration, then the actual length is divided by least radius of gyration, then we will get slenderness ratio. There are already I told that there are four methods are available. There are different methods are available to calculate the crippling load or buckling load. The important methods are Euler's formula, Rankine's formula, Straightman's formula, and Johnson's parabola formula. The crippling load the crippling load for the four end conditions are given in the diagram for Euler's column theory, using Euler's column theory. First one is when both ends are hinged, the crippling load can be calculated by using pi squared EI by L square. Okay, if the length is actual length, then this formula can be used. If the length is effective length, then the formula can be converted into pi squared EI by LE square. Similar way, we can calculate for all the four cases. Okay, if the effective length is given, we need to calculate the crippling load. The formula is pi squared EI by LE square. The relationship between equivalent and the actual length is given in the chart, where for the four end conditions, when both ends are hinged, both the length, effective length and equivalent length is same. When one end is fixed and other end is free, the effective length or equivalent is 2 times of actual length. When both ends are fixed, then the effective length is L by 2, half of the actual length. One end is fixed and other end is hinged, means the effective length or equivalent length is L by root 2. Okay, there is this is the formula to find the crippling load for long column using Euler's formula. The next one is Rankine's formula. The Rankine's formula is also useful to calculate the crippling load. The Euler's formula is only suitable for very long columns. If the column is short or medium, then we can use the Rankine's formula. The Rankine formula also gives the crippling load or buckling load. Here the formula to find the crippling load or buckling load is 1 by P equal to 1 by Pc plus 1 by Pe, where P equal to crippling load by Rankine formula, Pc equal to crushing load, which is sigma C into A. When the column is short column, you can calculate the crushing load by using this one formula, sigma C into crushing stress into cross section area, where sigma C equal to ultimate crushing stress, A equal to cross sectional area, where P equal to crippling load by Euler's formula. Already we know that how to calculate the crippling load by Euler's formula. Thank you.